So things are moving and we want to predict the motion. So for example, this little train, he's going along, he's getting faster and faster, but he's got constant acceleration. He's gone past A, we wonder what speed he's doing when he goes past B. Somebody's got a ball and they're going to throw it off the Eiffel Tower straight down. What speed will it be going when it hits the floor? Actually, somebody else has got it and they're going to throw it up in the air and then it will fall back down. What speed will that be going? When will it be at the height? At this height here, on the way up and on the way down, what times? How long will it be above that height? All fascinating questions you've probably never asked. To answer these questions, we could either ask the Magic 8 Ball, probably more reliable is to download the suvat calculator onto your phone and fill in the information that it's requiring, which is the displacement, the initial velocity, the final velocity, the acceleration and the time. Whichever ones you know, press calculate and it will tell you the one you don't know. But given that you can't take this in the exam, probably best I tell you the equations. Let's go back to the idea of a speed time graph. The important information we've got is obviously speed and time, but we've got a lot else going on this graph that we can use. So the final velocity and the initial velocity, both of these are velocities, and the graph has got constant acceleration. This body is moving with constant acceleration. Acceleration is the gradient of the line. So this has got a constant gradient all the way up this line, constant acceleration. So really obvious things we can take from this graph are time, that's the time across the bottom, and the initial velocity and the final velocity, and the acceleration, that's the gradient of the line, and the area under the graph is the displacement, that's how far the body has been displaced, not the distance travelled, the displacement from the original position. So these are our ingredients, and all of them you can see on this velocity time graph. Now it's important to note that most of these ingredients are not scalar quantities, they're vector quantities. So displacement is a vector, velocity is a vector, acceleration is a vector. What does that mean? It means it has a direction as well as a magnitude. Time is a scalar, it just has a magnitude because we assume we're going forward in time. So being a vector means it's got a magnitude, which is like a size, and a direction. Now in this case we're just going to be going left and right or up and down, so the direction part will just mean you contribute a plus or a minus, but you have to think very carefully with all of these first four ingredients whether they are positive or negative. That's really, really important. Okay, let's derive the first couple of equations. Let's use the fact that acceleration is the gradient of the line, which means it's the change in y over the change in x. Now looking at our graph, we see that the change in y here is the final velocity minus the initial velocity, v minus u, and the dx, the change in x, is t. So that gives us the equation v minus u over t. Multiplying both sides by t, and then adding u to both sides, we get v equals u plus at, and that's our first suvat equation. Let's get another one. Let's use the fact that area under the graph is the displacement of the particle. Now this area here is a trapezium, and the area of a trapezium is this, add this, the two parallel bits, times half the distance between them. So that gives me S equals, then I've got u plus v. Oops, not very good u, is it? U plus v, and then we're going to multiply by half the distance between them, and the distance between them is t, so that's half t, giving me my second suvat equation, S equals a half u plus v times t. The other three equations, and we'll come back to y in a minute, are, sorry, didn't mean to do that, v squared is u squared plus 2as, we can use that one. We've also got S equals ut plus a half at squared, and we've also got S equals vt minus a half at squared. So these are the five equations that we're going to use in suvat problems. Suvat being where we're looking at constant acceleration. It's really important that it's constant acceleration. The acceleration must be constant and the motion must be in a straight line. So how do we use these equations to solve the problem? So you start your question off by writing down SUVAT and seeing what information you've got. Have you got the displacement? Have you got the initial velocity, the final velocity, the acceleration assumed to be constant all the time? Fill in the information that you've got. Now, what you're going to have here, what you're going to find is that you will have 3 out of the 5 tick, and you will want a 4th one. So there'll be a 5th one which doesn't feature. So if you look at your equations, you'll see that this first equation has got no s in it, and this second equation has got no a, this equation has got no t, this equation has got no v, and this equation has got no u. So the one that's missing, the 5th one that doesn't feature, you can choose the equation that doesn't have that in and then use that equation to solve your problem. Now I've only shown you where these first 2 equations come from, so we'd better see where these 3 magic to themselves from. But actually all these 3 are is these 3 written in different ways, unbelievably, but true. So what you can do is get some paper, and I'm going to give you instructions for how to get these 3 from these 2, and you're going to see if you can do it yourself. Here are the instructions. See if you can pause the video after each set of instructions and have a go, see if you can do it. So to get this third equation, what you're going to do is you're going to make number 1 say t equals, and then you're going to put it in 2. To get the next one, you're going to make number 1 say v equals, and you're going to put it in 2. And to get this last one, you're going to make number 1 say u equals, and you're going to put it in, not in 2, you're going to put it in that one there that we just got. So this is the extra one here that sometimes doesn't feature. I think when you do physics they don't mention this one. They just say that there's 4 v equals u plus at, s equals a half u plus v times t, v squared is u squared plus 2as, and s equals ut plus a half at squared. They don't mention this s equals vt minus half at squared, but it's pretty simple. You just put u in as v minus at in here, rearrange, and you'll get this one. Have a go, have fun. So here's the problem: you actually have to learn these equations, and so the following song should help. Try and write them down at the same time as listening to the song, and bear in mind that one of the equations is missing. This song does not include the equation s equals vt minus a half at squared. But if you remember that s equals ut plus a half at squared, they're practically the same. The only difference is the minus with the v and the plus with the u. Enjoy the song.
V equals u plus at. 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 S equals ut plus half at squared. 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 V squared is u squared plus 2as. 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 S equals half u plus v times t. 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 V equals u plus at. V equals u